All right, so when we're doing right triangle trigonometry, one thing to remember is this only applies to right triangles. If there's no 90-degree angle, then none of this applies. So we use this acronym, SOHCAHTOA. So SOHCAHTOA is not a word, it's an acronym to help us remember what to do. And I was really shocked at one time. I had a student, and they're like, "Ms. Collier, we've been doing SOHCAHTOA, but I don't know what it means. So I don't want to make any assumptions." So there are 3 trigonometric functions that you learned in geometry. They are sine, that's what the S is for, cosine, that's what the C is for, and tangent. So sine, cosine, tangent, those are the 3 trig functions that you learned back in geometry. These are functions. It's an operation, and we do something with an angle, right? So we have the sine of theta, the cosine of theta, the tangent of theta. So we are using this symbol, and I am saying the word theta, Theta, which theta is just a letter in the Greek alphabet. And it's the one that we use most of the time when we're talking about angles. Now, there are other ways that we talk about our angles or label our angles, so just a few more that you should be familiar with. This sign is the symbol alpha. It's the first letter in the Greek alphabet. Sometimes it is used to mark an angle. And beta, which is the second letter in the Greek alphabet, is also used. All right, so theta, alpha, and beta, Greek letters that we use for angles, but also sometimes it may just say like angle K, where K is the vertex of your triangle. So these are all different ways that we might write the angle. But when we are talking about sine, cosine, and tangent, these are functions of angles. All right, so then this acronym SOHCAHTOA has O's and H's and A's in it, and those have meaning. The O stands for opposite in both places. The O stands for opposite in the beginning, and this O over here also stands for opposite. The H stands for hypotenuse. In both places. And then that A stands for the word adjacent. The word adjacent means next to. So each trig function is defined as a ratio of 2 of the sides in a right triangle. So when we have a right triangle, like let's draw one, and we have the right angle marked. The side across from the right angle is the hypotenuse. And then, in order to know where the opposite is, you have to start by knowing what angle you're talking about. So the sides are marked in relation to the angle. So if this angle here is theta, the one that I want to know about, then that means that the side across from the theta is the opposite OPP. And this one up here is adjacent ADJ. But if I had marked this bottom one as theta, then those names would be reversed. So your names go in relation to where theta is. And each one of our trig functions is abbreviated, and then it's equal to a fraction. So we write the sine of theta. We abbreviate sine, S-I-N. It kind of seems dumb to abbreviate a four-letter word, but we do it so that all the trig functions have three-letter abbreviations. So we do it for consistency's sake. But when you see this, please do not say sin. That is wrong, and you will sound dumb. Sine of theta is equal to, if you go up here in your SOHCAHTOA, opposite over hypotenuse. So that's how the acronym helps you. So the sine of theta is equal to the measurement of the opposite side divided by the measurement of the hypotenuse side. And then we get to cosine of theta. So we abbreviate cosine, C-O-S, stands for cosine. When you see that, you say cosine, don't say cos, say cosine. And when you look up here, you see that cosine is going to be adjacent over hypotenuse. That's how you use the acronym. So you put adjacent over hypotenuse. And then our third one, tangent, we abbreviate TAN. Tangent of theta equals, and again, if you go up to SOHCAHTOA, it'll tell you tangent goes opposite over adjacent. So you have opposite over adjacent, like so. All right, so we did these three problems on our whiteboard, and problems 1 and 2, we got the answers pretty easily. But problem 3, let's talk through this. We have an issue. Well, actually, what I saw a lot of people start with was they started with the sine of theta. And since this is our theta, this side is opposite. And the 12 is the hypotenuse. And sine of theta is opposite over hypotenuse, so sine of theta is 3 over 12, which is 1/4. And then right here is where we hit a little bit of a snag. We got stuck. And so what did we need to do to find this other side? What process did we have to use? The Pythagorean theorem. So we did not know our adjacent side. So whenever you're dealing with a right triangle and you have two sides but not the third, the technique would be the Pythagorean theorem. Some groups thought of that idea quite quickly, and some groups had to check in with somebody else to get that idea. So just a reminder to yourself, when we're missing this, what we did was the Pythagorean theorem. I'm just going to abbreviate. So the Pythagorean theorem says a squared plus b squared equals c squared. So in this instance, we'd have 3 squared plus b squared being equal to 12 squared. So then we have 9 plus b squared being equal to 144. We're going to subtract the 9 and take the square root of both sides. I'm going to just combine some steps. And we get down to b being equal to the square root of 135. That's the truth. B is the square root of 135. But we need to simplify all of our answers. Okay? So, we need to simplify a square root. So when we simplify a square root, we're looking for a perfect factor that can be multiplied to equal 135. So I need something times something that will make 135. And I want that first factor to be a perfect square.
9 times 15.
9 times 15 does equal 135. So then we take the square root of 9. The square root of 9 is 3. And the 15 would remain under the square root sign. So we're going to say that our adjacent side is 3 times the square root of 15. Now those groups that put the square root of 135 there, that was not an incorrect amount. It was just not a simplified answer. All right, so now we'll come in and do cosine of theta, which is adjacent over hypotenuse. So we're going to have 3 square roots of 15, because that's the adjacent, and then the hypotenuse is 12. And then we have to simplify that fraction. 3 and 12 are both divisible by 3, so that would be the square root of 15 over 4. That would be your final answer in simplified radical form. And then we're going to move on to tangent of theta. And tangent is opposite over adjacent. So the opposite is 3. And adjacent is 3 times the square root of 15. And again, we need to simplify. So 3 and 3 are both divisible by 3. So now this is going to equal 1 over the square root of 15. And that is the correct numerical amount, but that answer is not simplified. The agreed upon mathematical convention is that square roots don't stay in the denominator. So we're going to multiply by square root of 15 over square root of 15. And your simplified answer would be square root 15 over 15. So I am really concerned that you understand the trig ratios and how to set those up. But I also know that I'm going to give you some IXL to practice with this. And if you don't simplify the radical, IXL is going to say you're flat out wrong, even though you might have done the trig part correctly. Okay? So, I imagine that you will be like most of the other students I have taught for years, and you will get the trig correct, and you will forget to simplify, and then IXL will say you're wrong, and your smart score will go down, and you'll get upset. So, simplify, simplify, simplify. You need to remind yourself of that. Okay. So that is all a reminder from geometry. Now I have something else for you to look at before we get into learning something new. Okay. So we need to talk about the word reciprocal. So I have 3 sentences going across, and those things are the truth. I want you to read those to yourself, and then, based on those 3 examples, just think, you don't have to write, how would you define reciprocal? All right, talk at your tables. How would you define reciprocal?
Two fractions where the numerator and denominator are
No, Jordan. You can't.
All right. Now, we're making some observations, but many of these observations are not the definition. I want us to key in on the definition. So last block somebody said reciprocals are opposites. Is that true? No, opposites are negatives and positives. Like -3 and +3, those are opposites. I had somebody else say the top and the bottom are opposites. Is that true? No. I had somebody else say reciprocals are fractions and the numerator and the denominator flip. Well, is this a fraction? So do reciprocals have to be fractions? What is true about all of these problems? They all equal 1. That is the definition for reciprocals. So I need you to write that down in your notes. Reciprocals are 2 numbers whose product equals 1. And if you don't know, product means to multiply. It's the answer you get when you multiply. That is the definition of reciprocals. Reciprocals come in pairs and they multiply together to equal 1. But you probably first heard that word reciprocal back in 4th grade. And the first thing you might have heard, and a teacher may have even told you, oh, it just means flip. Well, let's talk about where that flipping comes into play. If I have the fraction 3/4 and I want to multiply it by something to equal 1, because reciprocals multiply to equal 1, isn't my fraction going to have the same number on the top as the bottom to come out to be 1? So if I have a 4 on the bottom here, I have to put a 4 here. So 3 times 4 is 12. And then on the bottom here, I'd have to put a 3. So that 4 times 3 is 12. And so that's why the numerator and the denominator end up flipped, right? So they do end up being flipped when you have it in fraction form. But the definition is not flip it. The definition is the product equals 1. All right. So now I want you to take that definition and we're going to apply it to something brand new that you've never seen before. Showing you the answers here. So, given that we know the sine of theta equals opposite over hypotenuse, And then if I tell you there's this new thing called CSC theta. You never heard of it before, I bet. And I tell you that it's the reciprocal of sine theta. Then what would its ratio be? That's what I'm asking you. I'm asking you cosine of cosecant, that's what this stands for, cosecant of theta, the ratio is a fraction, and Will says hypotenuse over opposite. Does everybody see that? Because if sine is opposite over hypotenuse, and this guy is the reciprocal, it has to be hypotenuse over opposite. Okay, so all three trig functions that you learned in geometry, each one of them has a reciprocal. But it's not like you have to learn 3 new things. All you have to do is know sine, cosine, and tangent, and then you just have to know what the reciprocals are, and then you'll already know all about them. So this is what I want you to write in your notes. Trig functions that we know about. Sine theta, cosine theta, tangent theta. Each one of them has a reciprocal. These are the abbreviations. These are the names written out. Usually nobody ever gets these 2 bottom ones mixed up. Tangent and cotangent are reciprocals. But the other 4 are a little bit tricky. My brain wants to put the C's together and the S's together, but that's just not the truth. Sine goes with cosecant and cosine goes with secant. So I always have to tell my brain the C's and the S's don't match up. It's the other way around. So I do not see any point in memorizing the fractions for these. I think all you should do is memorize these, sine, cosine, and tangent, SOHCAHTOA, and then do the reciprocal. So if I want to find cotangent of theta, I think like this. I think, oh, let me find the tangent of theta. And then after I find the tangent of theta, I'll just do the reciprocal, right? And then that's going to be way easier than memorizing a whole nother set of fractions. So I'm going to come in here and I'm going to label my sides. Side 25 is the hypotenuse. The side with the X would be called what? It's the opposite. So I'm going to look and I'm going to see I have an O and an H. So then when I think of SOHCAHTOA, if I have an O and an H, that tells me that I want to use the sine ratio to solve this problem. So then I will write an equation. The sine of 20 degrees, because that's my angle, is equal to x over 25 because that's opposite over hypotenuse. Now, once I've written that down, I am now following the rules of solving equations. So I will multiply both sides by 25. 25 divided by 25 makes 1, and x is by itself. And when x is by itself, it'll be time to type the other part into the calculator. So turn on your calculator, but before you press anything, look up top. My calculator says degree. Does yours say degree or radians? It's going to depend on if anybody else has used it today and switched it over. So I want to show you how to change back and forth just so you know. So this mode button right here, press it, press mode, and look 4 lines down. Do you see it says radian and it says degree? Sometimes we're going to be measuring in degrees, sometimes we're going to be measuring in radians. You have to make sure your calculator is set to the correct one. If it's not, you go here and you use your arrows to move around, and you get the one you wanted to have the light on it, and you hit enter, and then you do second mode to quit out of that screen. Okay? So whenever you're ready to work, you want to make sure that you look up there and see if you want to be in degrees, make sure you're actually in degrees. So then we would type 25 times, it's under a lot of glare, and then your sign button is going to be above the 7. You see sign. Your calculator will open a parentheses for you. You're putting in 20 for the 20 degrees. You're going to close the parentheses and hit enter. And since that's the side length of a triangle, we're going to round that to the nearest tenths. So we would say 8.6 units. Now I'm going to come put that on my triangle and see if my answer makes sense. How much is this angle down on the bottom? 70, right? The triangle has to add up to 180. This part's already 90. So the other parts have to add up to 90. So that's 70 degrees. We know that the longest side is across from the biggest angle, and the shortest has to be across from the shortest angle. So across from the right angle should be longest. Across from the 20 degrees should be shortest. And across from the 70 degrees would be the length that's in the middle. So does an answer of 8.6 make sense? Yes. I'm not saying it's right or wrong, but it makes sense. What if you got the answer 38? You would know it's wrong. Okay? All right. Go back to your boards, and I'm going to give you 2 to try like this. So on this number 1, everybody pretty much spied the fact that you have opposite and adjacent. There's no hypotenuse, so you're going to use the tangent function. So the tangent of 38 degrees is going to be equal to opposite side, which is 7, divided by adjacent side, which is x. Now, in the little music video, it said that these were just going to trade places. But that's not mathematically what's happening. I mean, it does end up that way. But we're doing algebra. We're solving an equation. So what happens is you multiply each side by x, which frees the x from the denominator because x divided by x is 1. You now have x times tangent of 38 degrees is equal to 7. Your task now is to get this x by itself. So you're going to divide by the tangent of 38 degrees. Tangent of 38, whatever it is, divided by tangent of 38 is going to be 1, because anything divided by itself is 1. So even though I have no idea what the tangent of 38 degrees is, I know the division is going to come out to be 1, and x is going to be by itself. And when x is by itself, it's time to pick up my calculator. And I'm going to do 7 divided by the tangent of 38 and close my parentheses. And I'm going to get that number on my calculator. And if I said to round to the nearest tenths, I would actually round to a 9.0. Because when you round to the tenths place, you need to actually have a digit in the tenths place. Now, let's just look for a minute. If this angle is 38 degrees, doesn't this angle here have to be 52 to add up to 90? So this answer of x should be bigger than 7, true story. So our answer makes sense.